This video will demonstrate how to change out the desiccant in the water trap on our Costech Elemental Analyzer. When coupled to an isotope ratio mass spectrometer, this instrument configuration can measure carbon and nitrogen isotopes in solid powders such as soils, bone collagen, or bacteria. This video series covers common maintenance procedures. Stay tuned to our channel for additional content related to sample preparation, common applications, and analytical protocols. Instruments and reagents are for reference only and do not represent an endorsement by ASU or Metal. We are not sponsored by any manufacturers. Your laboratory's procedures may differ. This series of videos is intended to assist newer users or laboratories with common maintenance procedures. It assumes some familiarity with the equipment, software, and protocols. If you have comments or suggestions, please send them to metal_asu@asu.edu. If you like our content, please like and subscribe. Supplies required include very fine quartz wool, anhydrous magnesium perchlorate, quartz turnings, Schott type O-rings, a mixing container and stir stick, aluminum foil, and a helium leak detector. You can find catalog numbers for the reagents we used listed in the video description. A water trap removes moisture from the gas stream after samples have been combusted at high temperature and reduce interferences during measurement. The desiccant is magnesium perchlorate mixed with quartz chips. Magnesium perchlorate is a common drying agent for gases that strongly absorb water from air, which can result in the column becoming packed solid and restricting flow. The addition of quartz chips helped to maintain the gas flow through the column. The issue that prompted changing the water trap today is that the peaks are shifted in retention time, and there's a double peak. Here are two spectra showing the peaks before and after changing the water trap. With an exhausted water trap, the peaks are narrow, with a double peak at m/z of 30. The N2 peak is shifted from 180 seconds to 154 seconds, while the CO2 peak is shifted from 272 seconds to 257 seconds. Before we remove the water trap, we need to protect our mass spectrometer from venting. First, we turn off the source with the gray sun icon in the isodat acquisition window. The box and trap values should go to 0, indicating the source is off. We then close the isolation valve to prevent the instrument from venting when we remove the water trap from the sample line. The isolation valve is accessed through a port in the top of the mass spec. Be careful of the capillaries that come off this section. You don't want to over-tighten the isolation valve, but you'll know it's closed if you watch the vacuum on the monitor. When open, the vacuum is around 10 to the minus 6 millibars. When closed, it will be about 10 to the minus 8 millibars. We always use new seals when changing the water trap. We'll need two, one for each end of the column. They're Teflon on one side, silicone on the other. The aluminum foil helps with cleanup. We use a small disposable plastic cup for mixing the quartz chips and the magnesium perchlorate and stir it with the shaft of a wooden Q-tip or similar item. Keep the magnesium perchlorate closed until the last minute to minimize water uptake and store it in a desiccator. Now that we're ready, we'll take out the water trap. Unscrew the top connector. Here's what the end connector looks like, and here's what the seals look like. We'll also remove the bottom connector. Each end has a plug of quartz wool to keep the reagents inside the column. Pull out the plug with the wooden shaft. Tap out the reagents into a hazardous waste container and remove the quartz wool plug from the other end and empty out the rest of the old reagents. Clean the column by pushing a Kim wipe through it. We'll now add a new quartz plug to one end. Make sure it's tamped down to keep the reagents in place, but not so tight that it would restrict gas flow. Mix new reagents in this cup. We generally use 5 to 10% quartz chips, and the rest is magnesium perchlorate. If you had a small funnel, you could use that to tap the reagent into the column. However, we're going to just bend the mouth of the cup to shake it into the column. Every so often, wrap the column sharply so the reagent will pack down. This particular batch of reagents has some fine powder and big pieces, which is not ideal. It's much better to have an even, medium particle size to ensure even packing that isn't too dense. Place quartz wool in the other end of the column once the reagents are packed. Be sure that the lip and threads of the column are clean so that we can get a good seal. Orient the seal with the correct side toward the column. Align the column with the connector and then screw the red connector cap onto the column. It's typically better to tighten the lower end first because the gas is still flowing and can make it harder to align the column end to the connector. After we've replaced the water trap, we need to check for leaks with a helium leak detector at the connections we've replaced. The flow meter has a stylus that will detect gases. When turning it on, make sure the exhaust port at the top and the reference gas port on the back are clear. It will zero itself. A solid blue dot indicates it's ready to measure. If the blue dot is blinking, the meter needs to be recharged. If you move the meter too fast, sometimes it will read a value. We want it to read 0, so we can zero it with the button on the front. When we check the connections, the meter shows that there aren't any leaks, or we would see the LEDs on the meter light up. However, we need to double check that the meter is actually working. The easiest way to do this is to slightly open the valve on the zero blank autosampler, which is flushed with helium. You can see now the meter is maxed out. Next, we need to condition our new column. For that, we need to make sure we're in the correct menu of the Elemental Analyzer. We don't want to be in the remote menu. 1020 degrees C is the temperature of the left-hand combustion furnace. 650 degrees C is the temperature of reduction of the right furnace. The GC column temperature is from 30 to 110 degrees, but the working temperature is 55 degrees C. We're going to change the GC temperature up to 110. You just type 110 in the keypad and hit enter. The LED for the oven should light up red so you'll know it's working. For the GC column, it's critical to make sure there are no leaks. If there's oxygen or air in the column, at high temperatures it will ruin the stationary phase. That's why the leak check is so critical. So now we'll leave this until tomorrow morning when we'll turn it back to 55 degrees. It will cool down in perhaps 4 hours or half a day. After that, we'll run additional tests to see if the peak shape has improved. You always want to record when you do maintenance. Go to the Home menu, and this value is the number of tins that have been through the instrument. We typically track this value and calculate how many tins have been through since the last water trap change. If 1,000 have been through it, it will need to be changed. The reaction column will last about 500 tins, but we will often change both columns at the same time. The reaction column change will be shown in a future video. Thanks for watching. If you like our content, please like, subscribe, and follow us. If you have suggestions for other procedures you'd like to see, please leave them here in the comments.